Hello everyone, welcome to my YouTube channel. Today I'm solving Leetcode question 188. Best time to buy and sell stock. Question number 4. The idea for solving this problem is very similar to my other videos on the best time to buy and sell stock related question, for example, with cooldown or with transaction fee. In this problem, you are given an integer array prices, where prices I is the price of a given stock on the ith day, and an integer k. Find the maximum profit you can achieve. You may complete at most k transactions. Note that you may not engage in multiple transactions simultaneously. You must sell the stock before you buy the stock again. So let's take a look at one example to have better understanding of the meaning of this k, because this can be really confusing. So in the example 2, k equals 2, and then this prices array is given. The output is 7. You can buy on day 2, sell on day 3, and buy again on day 5 and sell on day 6. So you get a total profit of 4 plus 3 equals 7. So in that case, if you interpret this number of transactions as like, for example, buy counted as one transaction, sell counted as another transaction. In this case, given k equals 2, you may just perform buy and sell once. But here, in this problem, this at most k transaction actually means that you can do buy and sell at most k times. So the idea for solving this one is using recursive memoization. You can also solve it using dynamic programming approach, but I find this recursive with memoization the most intuitive, especially during the interview process. When you are given this problem and you have to solve it within limited time, and then you have to explain it to the interviewer clearly, and then you are nervous as well. So I think this one, the recursive with memoization, is the most intuitive solution to me. So the idea is consider for each day. On the ith day, you have two options: do nothing. First option, no transaction, do nothing, do not sell or buy. And then second option, you have a transaction, you perform transaction, you can either buy or sell. Buy or sell depends on if you are holding a stock or not. If you hold a stock, then you can only sell it. If you do not hold a stock, then you can only buy a stock. So the current profit is actually the maximum between option 1 and option 2. So what is the inputs to the recursive function? We have the I. We want to keep track of the ith day. We also keep track of whether or not we are hold the stock, because this indicates what kind of transaction you can perform. It's a Boolean variable. However, hold status can be inferred from the number of transactions left. That's very important to track, because this problem has a constraint that you can perform at most k transactions. So you can buy and sell at most k times. So I use a variable called count to indicate the number of transactions left. So in this case, I keep track of count. Buy counted as one transaction, sell counted as another transaction. By my definition of count, the initial value of this count is 2 times k. So my hold status can be inferred from count. Is this the remainder of count divided by 2? So when count is an even number, I do not hold the stock. But if a count is an odd number, which means, okay, I buy the stock sometime in the past, but I have not sold it yet. So in that case, our inputs to the recursive functions are I and the count, which is the number of transactions left. So let's start coding. So in that case, since it's memoization, I use a memory dictionary to keep track of the values I have already calculated. And now I define my recursive function with input I and the count. So for the recursive function, I need to consider the base case. So here the base case is if I is greater than or equal to the length of prices, or if count is less than or equal to 0. I do not have any transactions left. In that case, I just return 0. And then next step, with memoization, I need to check if this value has already been calculated before. So if I and count in memory, then I just return the value. so that I do not have to repeatedly calculate them over and over again. So then let's move to, okay, option 1. So no transaction. That is easy. So this answer 1 equals you call this function for the next day. And then option 2, transaction. In that case, you first get the hold status to check whether or not you have a stock. That can be inferred from the count. And then if you hold a stock, then you can sell it. In that case, the profit is, when you sell the stock, you gain prices I. This is the amount of money you gain by selling this stock. And then that is plus the profit you get from the next day. Since you perform one transaction, this count becomes count minus 1. Else, if you do not hold, in this case, you purchase a stock. When you purchase a stock, you spend this amount of money minus prices I, because you spend this amount of money to purchase that stock. And then it's also I plus 1, count minus 1. And then your final answer for this day is actually the maximum between these two. So the maximum between option 1 and option 2. And then after that, you just return this one. You call this recursive function. And then when you call it, your I starts at 0, your count starts as 2 times k. So this is our solution.